Dear students, welcome to my channel. This is model question paper 2. The program is electrical and electronic engineering semester 2. The course is concepts of electrical circuit. Subject code is 25 EE 21I. This is a model question paper 2, 3 marks question. The question what they given, explain dielectric strength with an example. First we should know what you meant by dielectrical strength. So dielectrical strength, it is a maximum electrical field that can insulating material can withstand without breaking down. So it should be withstand without breakdown if you apply the electrical field on materials. Okay. Here they given a small explanation. When you voltage across the insulator increase behind the limit, it will lose the property. See, if you apply voltage will be more of a particular insulating material, it will be more than that, the insulating property going to reduce. Based on this, it will cause a breakdown and current flow through the material. Current will be flow through the material. Example you can give, air is an dielectrical strength about 3 into 10 raised to 6 V by M. V nothing but voltage exceed the value, the spark breakdown occurs. When the voltage will be exceed, the spark will be occurs. Next, list types of charging battery systems. So it is there is a different types of, one is a constant current charging. In a constant current charging, the name only indicate current will be keep it constant throughout the charging. Second one is a constant voltage charging. It means the name only indicate voltage we have to keep the constant and current going to decreases gradually. Next is trickling charging. Okay, a small current supply continuously to the main full charge, that is trickling current. Next is floating charging. Floating nothing but whatever battery you are connected to the main charger without overcharging. You can give an floating nothing but floating we can give an batteries. So next question is explain significance of MMF and reluctance in a magnetic circuit. MMF nothing but magnetomotive force. Okay. So magnetomotive force, when you driving the force, magnetomotive force, which will be the product of magnetic field and in a magnetic circuit. If you similar voltage of electromagnetic force in an electrical circuit, if you increase the MMF nothing but magnetomotive force, more magnetic flux will be produced. What do you mean by in the reluctance we can call it as an R. So in the reluctance nothing but it is an opposite flow of the flow with a magnetic flux. Same way, similar resistance in the resistance will be similar in the electrical circuits. If you increase the reluctance, less magnetic flux. So when the relationship will be the magnetic circuit, it will be N M F divided by R. You can give the relationship for magnetic circuit. Next question, difference between static and dynamic inducted electromagnetic force. Static name only indicate it is a stationary. So in the static, it is a conductors is stationary. It will be a static. It will not, there is no movement. So electric magnetic force due to changes due to magnetic flux. The magnetic flux should be depending upon the electromagnetic force. There is no physical movement. Name only indicate there is no physical movement on electrode. Example you can give an transformer. You cannot, there is no physical movement. So coming to the dynamic electromagnetic force. So dynamic nothing but conductor moves to the magnetic field. Here conductor moves to the here stationary, that's it. Next difference, electromagnetic force induced due to cutting magnetic flux. When it is will be induced, if you cut the magnetic flux, it is required magnetical motion, it is required mechanical motion. It is a required mechanical motion. You can give an generator. You can give an example for a generator for the electromagnetic magnetic flux. Next is given a short note on vector representation of AC quantities. How you are going to represent vector voltage. AC quantity, it is a current, alternative current. AC nothing but alternative current. It will be like a voltage and current represent using vectors, okay, phasors. It will be both having magnitude and phase angle of the quantity. Okay, the vector will be rotate anti-clockwise direction with an angular velocity. If the vector is rotated anti-clockwise direction, it will be produce an angular velocity. The angle between the vectors and phase difference between the voltage and current. If you difference in the angle, the phase difference between the voltage and current. One is resistivity circuit. It will give a voltage and current in a phase. It is an inductive circuit, current lagging voltage. It is a capacitive circuit. It will give the current leads voltage. Next will be define self and mutual inductance with a one application. Self, the name only indicate it's a self. Okay. The property of the coil by which its opposite changes in a current induced EMF force itself. Induced self will be induced. Application you can use for chokes, inductors in a electrical circuit. There you can use. Coming to the mutual inductance. Mutual nothing but it's a combination. It is a property changing current in one coil induce EMF force to another nearby the coil. Near coil. It is a mutually conduction means a combination. One force it will be produced, it will be reaches to another coil. So we can use it for transformer. Whatever induced in the transformer, it will connect it to lines and all. No. See more information. Please subscribe my channel and share and support. So I am going to upload a model question paper 3 also. Thank you.